Hi, this is Justin Murray, and in this video I'm showing off my spectral renderer using Vulkan. This is rasterized and not a ray traced spectral renderer. Um, so everything is rendered using 5 wavelengths: 615, 530, 460, 565, and 490. 615, 530, and 460 are about red, green, and blue, and 565 is a greenish yellow, and 490 is cyan. And all the materials and lights use these wavelengths. So the lights have a radiance value, that's basically how bright it is. And then the percentages of each wavelength that the light consists of. All the lights right now are equal amounts of each of the wavelengths, which does not equal white because some wavelengths are brighter than others in human perception. So it looks pretty white, but if you look at the hue, it is in fact mostly green. And if you went into a program and looked at a screenshot of this, it would be slightly green. But each of these translucent objects has a different have different reflection and transmission colors, as you can see in the GUIs for each of them, and they cast colored shadows based on their transmission colors. So over here on the far left, I have these two translucent squares, and they both look kind of yellow, but this one on the left transmits green and red 615 and 530 to look yellow, and it reflects a little bit of that same color. This one on the right only reflects and transmits 565. So if I remove the blue, greenish yellow, and cyan, you can see the light's just yellow now from red and green, but this one seems to be transmitting none of that light and reflecting none of it either. But if I were to look over here, you can see it is transmitting some of the 565 nanometer light from those lights over there, but looking over here, nothing. The shadow behind it doesn't even appear. But then change it from that to just 565. Now that one is totally black, and this one isn't. Let me just make that again. Over here, this piece of glass is it's dichroic, which means it reflects and transmits different colors. So if you look at the reflection transmission, it reflects mostly blue and cyan, but transmits red, green, and yellowish color. So the shadow it casts is pretty yellow, and the light it reflects is blue. If I were to look over here and then turn the brightness of this light down, you can see it actually starts to look more yellow because the light behind it is brighter than the light it is reflecting. And as I move it around, you can see that as well. How it changes color based on how bright the light reflecting off of it is. And then this over here is just it's like a normal piece of glass. It just reflects and transmits all the colors equally. This is a not very clear piece of glass. A real piece of glass would be more like, 99% transmittance of all the colors like this, and uh, maybe 1% reflection, probably less than that, actually. Yeah, you can see now it's more clear, and you can basically not even, you almost can't see the shadow. It's basically not there. You can see here it casts on this monkey head just fine. Monkey head reflects all the colors evenly. It's white just like the ground. I move it over. Well, if I move it forward, you can see it does cast a shadow. Oops, moving the light. You can see it does cast a shadow on here, and the shadow on the glass does not look black because it's still translucent, and the light from back here is shining through the side of the glass, but nothing's being reflected. You don't get any blue here. And if you look at the back side of this glass, it's totally yellow because there's no light being shined on this side. There's no blue light to be reflected. If I take this light on the far right and make it magenta, start moving it around, you can kind of see some cool stuff. This way. Go over. This still looks pretty blue because there's a lot of blue light in the magenta light. And you can see it kind of casts a reddish shadow. Let me kind of turn this light off, actually. Cast a red shadow because that's part of the light it transmits. Move it over. Oops. Move it over some more. And this looks kind of weird. It looks like the magenta light is casting a green shadow, but that's not actually what's happening. It's just relative to this light shining here and the magenta light around it. So if I were to get rid of the brightness of this first light here, you'd see this is actually a black shadow, but it only looks green because it's surrounded by magenta and is being lit by this light here. This shadow is being lit by this light. And then this light, it looks like this one is casting a magenta shadow, even though the square only transmits the yellowish green. And that's, again, the same reason. It's just that it looks dimmer compared to the light around it, and is still mostly magenta because of this light over here. So you can get some pretty interesting effects here. If I make this 100% red, make this 100% green, you get kind of a yellow in the middle, and this is transmitting the red, but no, sorry, it's not transmitting the red. It's again, it only looks like that because of this light here. Another thing is, because there are 5 wavelengths, you can get the same color using multiple wavelengths. So just focusing on this light here. If I see here, right now it's just green, and this is kind of a bluish green. This isn't, you can see by the hue down the bottom right, but I can, so this green, this is a monochromatic green, 530 nanometers. The display can't actually show this, so it is mapped to be within the sRGB gamut, and that is the hue it maps to, and the linear sRGB value above that is its sRGB value in the chromaticity diagram, which is outside the gamut, which is why there's negative values and values over 1. So I can get that same hue by mixing 0.377% or 37.7% of that and 62623, and that is almost the exact same hue, I think. But it is not as bright. If you look at the relative luminance here, it's 77. If I go back to just this, it's the same hue, but it is at 94 relative luminance. And that is because that wavelength is actually brighter. In real life, you would see that as a different color and a brighter color, but they map to the same color when rendering in sRGB. And I preserve the luminance when doing that so that there is at least some difference. You at least perceive the brightness of the light correctly. And again, because these lights, these wavelengths do not have the same perceived brightness. Red, relative luminance 75. Yellow is, there we go, 99. Blue is very low at 35. But if you were to take screenshots of these and look at them in an image editor, it would show you that the luminance is correct. The yellow is brighter than red, it's brighter than the blue, and so on. And the other thing, luminance. So the luminance and relative luminance. The first value is the luminance using the weights calculated for RGB, because they contribute different amounts to the luminance. That is not linear in human perception. So twice the luminance does not mean twice as bright to the human eye, but the relative luminance is linear for human perception. So, 80 is twice as bright as 40 in that case. The colored shadows do overlap. So if I were to make this like white again, see if I transmit red and blue, or red and blue with this one, and then transmit, say, only blue with this one. You got a magenta shadow here, a blue shadow here, and here it's also blue because that's the only color they both transmit. But it's a darker blue because it has to go through to both of these filters, reducing the amount of blue light. If I were to make this one transmit cyan, the magenta square here does not transmit any of that color, but this one does. So this shadow is actually black. It might look like it's a certain color because of, relative to what's around it, but this is just a black shadow. Don't think I have anything else to show off here. I could make this one transmit and reflect 100%, so it's kind of like doubling the total amount of light. So it's basically emitting light here because it's reflecting like 100% of the light of those wavelengths, but it's also transmitting that much. So it ends up being brighter than it should overall. You can see the colors mixing, the different lights here. I think that's it for me to show.